Have you ever wondered what kind of security there is when you're sending out an email to your friend? You could be sending a WhatsApp message, or you could be submitting a form with the user and password. You want to make sure that that information that you're sending, only your friend or your intended party is able to open it up and read it and really understand. Um, I want to explore that a little bit, how the internet, how the security on the internet is in place. What are the different steps? What are the different algorithms in which the security is ensured with these kind of communication? Let's simplify a few things here first. Let's imagine there's no internet. There is no computers. You're just trying to send a letter to your friend. How would you go about sending that out? Well, you'll send it to the mailbox. Uh, your friend house. It would be received at your friend's house. But someone at your friend's house could, potentially open up the letter and look at the content of the letter. So it's similar problem with the internet as well that we're trying to fix. So let's try to fix it outside of the internet first. Let's say, how would you go about solving it when you're just dealing with letters? Um, well, one option is that you buy a lockbox, right? Put the letter in the lockbox and send the letter box to your friend. Yeah, it's going to be a little bit heavier, more cumbersome, but that at least ensures that no one in between is able to unlock the box. That's good. So your friend receives it, or someone at your friend receives it. But even your friend can't do anything with it, right? So when you place the letter inside the lockbox, it was locked by a key. So you need the same key or a duplicate of the same key to unlock it as well. So you either have to fly or you drive over to your friend's house and give him the key. The issue is that that's really cumbersome. It doesn't really make sense in a lot of the cases, so you're really stuck with this kind of difficult step to transfer over the key. Um, Obviously, it might make a little bit sense when you are, planning to communicate hundreds of messages throughout the year with your friends. So, for those cases, it might actually make sense, but still, it is hard to do. And imagine you're going to be sending different letters to all your different friends that you have. That's going to take a while. I mean, either you're going to drive, fly over there, so it's really not practical in the long term. So that problem is still there. We'll solve it, but let's go through a few other steps that we have. So let's go look at how can we at least get to a little bit better way of communicating by at least using that lockbox analogy that we have. So a lockbox analogy on the digital side is you have these algorithms that you pass your email to, or any kind of communication that you're trying to send out to your friend. You have to run through an algorithm. The most basic algorithm you have is the symmetrical encryption. So in encryption, there are two words that are really relevant. One is called encrypt, the other one is called decrypt. So similar to the lockbox, so the lockbox analogy is your symmetrical encryption. The key analogy is you've got your key or password, but the function of locking and unlocking, it's called encrypt, and the unlock is called decrypt. So that's kind of like the analogy that happens. Let's go and explore what that symmetrical encryption looks like. I have a demo application here. So you'll see, as an example, it's a Node.js application here. It has a message, it has a key, and then it has those two functions that I was talking about, right? So there it has the encrypt and it has the decrypt. Let's debug through this and see what this piece of code is doing. So the first one is it's setting up a message, simulating that, the email that you might be writing. The key, that's your password or the key, is the same analogy as in the lockbox, so that's your key here. This could be anything. So I've just pretty much decided that this is my key. You take that key and you pass this key and the message into this encrypt method. So this is what it's going to do. It's going to translate or transform your message, which is this is a sample email to my friend, to this encrypted text, right? So let's actually print this out here. So encrypted text, right? So this is the text. Now, if someone in between you and your friend receives this text, it has no meaning. You cannot do anything with it. But if your friend has the same key, they can decrypt it now. So let's decrypt it. So it's a decrypt function that I have. I'm using a public library here, NPM library. This is crypto.js. Now, what it does is it's going to decrypt the text of the same text that I had, which was encrypted, pass in the same key. It has to be the same key to decrypt, right? So now I have this decrypted text. So if I were to console log this, my next step here, so this is a sample email to my friend. So that's the decrypted text right there. Let's actually rerun this application. Let's change the key to something else. Let's change it to, this is the wrong key, right? So let's run this application again. Now the expectation is that the decrypt function is going to not be able to decrypt. So let's take a look at what that decrypt text is. Yeah, so it was an empty string. So you would not be able to decrypt unless and until you have this exact same password here, right? So if I were to change this again to exactly the password that was used to encrypt, this is my secret password, right? Let's run it again. There we go. Let's take a look at, yeah, this is a sample email to my friend. So you have the exact same message that you received. So that's your analogy to your lockbox into the digital algorithm way of doing things. This is pretty cool. As long as you're able to transfer that password over to your friend, which could be possible. Maybe you call that person up and you exchange the secret password, and then after that you can start communicating. Works great for this one-to-one communication, but again, let's go back to the problem of communicating with multiple different friends, multiple different users, or people you want to communicate with. This is going to not scale well. But we're getting very close to solving that key transfer issue. Now let's go focus on the lockbox again. The lockbox has two functionality, or rather, the key has two functionalities. One is to lock, the other one is to unlock. So what if we have a specialized lockbox, right? And we are able to separate these two functionality into two different passwords. So if you have ever been in a hotel, usually they have a lockbox there. It's a digital lockbox, right? So you enter a 4-pin, you're able to lock it. You need the same 4-pin to unlock it as well. But let's imagine you have a specialized function on it that is a separate key to lock and a separate key to unlock, right? So this way you've actually split the functionality of a lock and unlock into two different functionality. Now, if you can think a little bit ahead, once you have achieved this specialized lockbox, you can easily broadcast your lock password to anyone that you want to communicate with, right? Without any security issues. So keep that in mind. That's kind of the benefit that you get from this. So similar to that lock example that we are just looking at, so this is your simple lockbox. I call it the pin lockbox. You have similar algorithms that's there. So we've looked at the symmetrical encryption. We did a demo on this, right? So it requires one password that we put in to encrypt and decrypt. We also have this asymmetrical encryption. This has two keys to it. One is called the public key. The other one is called the private key. So again, it's really awesome. You can achieve the encryption by using two different keys. So let's take a look at how we can transfer that letter or email through asymmetrical encryption. Again, I'm the one sending. So I would use the public key of this algorithm, encrypt the message, and send it over to my friend. On my friend's side, he would take his own private key and decrypt the message from that perspective. So you've kind of actually really worked this out. On the digital side, you can have a website that is broadcasting your public key. So that way, anyone who wants to communicate with you, they can go and grab that public key from you and to encrypt that message for you. So this works really fine. What's the catch? The catch is performance. Right, so the symmetric encryption is a lot faster than asymmetric. So if you imagine we've got billions of communication going on over the internet, so this performance gap adds up, right? So we need to still find a way which is performant as well. So we can have a hybrid solution here, right? So it's a two-step process. So instead of sending your letter initially and encrypting it, what if you take this key, the same key, so instead of communicating on an ongoing basis through asymmetrical encryption, what you do is you take the key. So this is a symmetric key, right? So you use that key to transfer that key first, right? So we're solving that initial problem that we had of transferring the key. So we can use the asymmetric encryption to transfer the private key. Once you both have the same private keys, you can go back to the symmetric encryption and communicate further messages with your friend, right? So if you've got multiple WhatsApp messages, you can keep using this private key that you have to encrypt and decrypt, right? So you have kind of solved that problem of encryption and ensured in a performant way to communicate that key to communicate with your friend. Now, I mentioned a little bit earlier how you can broadcast your public key. So again, anyone who wants to communicate with you or to your friend needs their public key. So that's kind of the catch in how this algorithm can work. In fact, when you're actually communicating with any website, if you go to the security of that website, there's an SSL certificate that goes attached with it. To simplify that, all it is just one additional information that you get from that website. So for example, in this one, I'm going to Miro.com. This is the application that I'm using for this whiteboard session that we have. If I click on this lockbox, this is Safari I'm using. So every website has a certificate as well. And certificate is really what it is, just this extra information on top of what you're visually seeing. So if I go look at the details of the certificate, there's tons of other information that you have. But you also have this public key information here. It's telling you what kind of algorithm you're going to have. And this is the piece here. This is your private key right here. So in fact, when I'm actually communicating with this Miro website, every communication is encrypted. It's encrypted by using this public key, right? So this is how security takes place on the internet. I hope this was useful and you found this useful. Thank you for spending the time with me. Thank you.